So, today we're going to tackle a massive, and I mean massive question, but with an answer that's surprisingly simple. We're going to explore this one idea that connects the absolute tiniest quantum jitters to the grandest cosmic structures you can imagine. Get ready for the popcorn universe.
You know, it's one of those questions that feels almost too simple to even ask, right? I mean, just look up at the night sky. You see stars, galaxies, planets. You see us. But why? Why isn't the universe just this perfectly smooth, totally boring soup of energy, just spread out evenly everywhere?
Well, the key to unlocking all of this is a simple and honestly a surprisingly familiar analogy. It's an idea that connects the unbelievably small with the unimaginably large. And it all starts here.
Okay, so to really get this, we've got to go way, way back. Back to the very, very beginning. Back to a time before the pop, when everything that would ever exist was crammed into this single primordial kernel. It's almost impossible to wrap your head around, but the very early universe was incredibly uniform. Just try to picture it. It's like a single, unpopped popcorn kernel. Super dense, super hot, and with basically no distinguishing features. A state of near-perfect smoothness.
Right, but that perfect, boring smoothness, yeah, it wasn't going to last. Something had to come along and break that uniformity. And this is the moment the universe gets interesting. This is the moment the very first seeds of cosmic structure were sown. So what was the catalyst? What kicked all this off? Something called quantum fluctuations. See, at the most fundamental level, the universe was just buzzing with these tiny, random jitters of energy. Don't think of them as big explosions, but more like microscopic ripples in that otherwise perfectly smooth fabric of space-time. Okay, so let's walk through how this all went down. You start with the universe in that uniform, smooth state. Then, these quantum ripples appear out of nowhere. And within those ripples, for the very first time, particles start to clump together, to congeal. And in that moment, bam, everything changes. The universe essentially pops from that tiny quantum state into the huge, lumpy cosmos we know today.
And this quote, it just nails the whole idea, right? The formation of matter wasn't some slow, gradual thing, no way. It was explosive, just like a kernel suddenly bursting open into a piece of popcorn. Each one of those little clumps of matter was its own little pop.
But, the popping was really just the opening act. Because as soon as matter existed, two fundamental forces jumped into the ring for this epic cosmic tug-of-war, a battle that would end up shaping the destiny of the entire universe.
So let's meet our two contenders. First up, you've got gravity, the clumper. Every single time a piece of that popcorn matter appeared, it created its own little gravitational field, always trying to pull other matter towards it. And its opponent? Dark energy, the expander. This is a mysterious force that was there from the start, acting like a kind of anti-gravity, constantly pushing everything apart.
Now, here's the really mind-bending part. You'd think a pushing force and a pulling force might just cancel each other out, right? Lead to some kind of stalemate. But that is not what happened. The constant outward push of dark energy actually amplified those tiny initial clumps. It made the empty spaces between them bigger, which then made it easier for gravity to win the battle inside those denser regions. This cosmic fight actually sped up the formation of all the structure we see.
So let's fast forward a few billion years. After all this cosmic popping and pulling and pushing, what do you get? What does our universe actually look like?
You can really see the whole story unfold in just a few key steps. It starts with that smooth, primordial kernel. Then you get the first pops of matter, all thanks to quantum fluctuations. That kicks off the cosmic tug-of-war, which just accelerates all the clumping. And the result, today? Well, it's our universe. A giant cosmic bowl filled with galaxies, stars, and planets.
Okay, so let's just recap the whole incredible story, right? The universe didn't start with a bang so much as a smooth, even hum. Then, tiny quantum jitters came along and broke that perfect evenness, planting the first seeds of structure. From those seeds, matter literally popped into existence. And finally, that cosmic battle between gravity's pull and dark energy's push sculpted those early clumps into the vast galaxies we see today.
It's an absolutely incredible story of how we got from, basically nothing to everything. But this popcorn universe idea, it leaves you with this one last kind of mind-blowing thought to chew on. If our entire observable universe came from just one of those events, from a single kernel that popped, what else might be out there in the cosmic bowl?